In this vector question, we are asked to find a ratio of two vectors, two distances here, OE and CE. OC is here and OE is here. It tells us that OCE is a straight line, C being a point on AB. To start with, you're going to want to draw a line from O to E through C. The lovely examiners have created this such that if you do try and draw a line through, it actually doesn't go through all 3 points. So you just have to approximate that it goes through, but you assume that it does. I mean, that it does tell you that the diagram is not drawn accurately. I assume the reason why they haven't put the C in exactly the right place is because it forces you to do a vector method, which is what they want, rather than trying to do some sort of geometric thing based off the diagram. So we'll assume that C is on the line OE, and the method I'm going to show you, I'm going to write probably more than you would write in the exam, but I want you to try and understand and follow through the logic of what I've done in terms of each of the individual steps. But in the exam, you could probably shorten what you're writing by at least half of what I actually produce. Once you've drawn the line on, hopefully this will remind you of the sort of vector questions when we have two lines that cross and we want some sort of journey to a point where they meet. And what we need to do is work out two different routes there. So one using this line and one using the other line, and we'll use lambda and mu. We'll form two simultaneous equations. We'll solve those and we'll know then our vector to go from, in this case, O to C. The only difference with this is there's an extra bit because we want to find the ratio. So let's just focus on, first of all, the journey from O to C. My first way of doing it, I'm going to go to go O to C, I'm going to go O to A and A to C. So I'm going to tell the examiner that's what I'm doing. So I'm going to write vector O to C is equal to O to A plus A to C. Now I know what O to A is. O to A is 2A. And I do not know yet what vector A to C is. So let's look at vector AC. So vector A to C is part of A to D, or part of A to B. Now, A to B, I know what that vector is because I can go this way here, AO and OB. So I'm going to use vector AB, and I'm going to say it is a proportion of AB. So I'm going to say that AC is equal to lambda multiplied by AB. So lambda represents the proportion of vector AB. Now, of course, what is vector AB? Well, AB is going to be minus 2A plus 2B. I can take that straight from the diagram. So minus 2A plus 2B. And what I'm going to do is expand this out. So I'm separating my A term and my B term. So I have minus 2 lambda A plus 2 lambda B. That is my AC. Now I can put that back into my expression at the above here. So I now know that OC is equal to 2A plus minus 2 lambda A plus 2 lambda B. Now let's tidy that up. Again, collating the parts with A and the parts with B. So I have 2 minus 2 lambda of A plus 2 lambda B, and that's certainly picking me up points from the mark scheme in the exam. Now I need a different route to go from O to C. So instead of going along here and along this line AD, I'm going to just say that O to C is a fraction or proportion of the line O to E. So let's write this one in blue to keep it separate. So I've got O to C is equal to mu O to E. Now what is the vector O to E equal to? Well, I could write that as going O to D and D to E. So it's O to D plus D to E, which is equal to O to D, which I don't actually know at the moment, plus 7A plus 3B. So let's look at vector O to D. Well, vector OD could be written as OB plus BD. So let's do that. OB plus plus BD. So BD. OB I know is 2B. And BD I need to calculate because I don't know. But BD here is part of this ratio here, A to B, B to D. The ratio is 1 to 2. So BD is twice as long as AB. It's twice the vector. So what is the vector of AB? Well, we know vector of AB because it's minus 2A plus 2B. Let's write that down. So BD is equal to double AB, which is 2 multiplied by, and the vector AB we know is minus 2A plus 2B, which becomes minus 4A plus 4B. So therefore I know that O to D is equal to 2B plus minus 4A plus 4B. So we have minus 4A plus 6B is my vector of O to D. And if that's O to D, then I know that O to E is equal to minus 4A plus 6B plus 7A plus 3B, which then works out to be minus 3A plus 9B. And therefore O to C is equal to mu multiplied by that, minus 3A plus 9B. Expanding that out, I got minus 3 mu A plus 9 mu B. It's important to mention at this point that when we are writing our vector OC in two different ways, we make sure we separate out our A and our B parts of the vector, and then we can actually look at what we call equating the coefficients of A and equating the coefficients of B. So I've rewritten them here. So now we got two simultaneous equations that can be formed. So what we will write here is that the coefficients of A, so 2 minus 2 lambda, will equal 3 mu. I'll call that equation number 1. And leave a little space, and then I'm going to say with the B's, I've got 2 lambda equals 9 mu, and that's equation number 2. So that's the first one is equating the vectors for A, and the other one is vectors for B, or the coefficients. Now, I can combine these two now, and I can actually substitute equation 2 into equation 1, because I have a 2 mu here and a 2 mu here, and these 2 mu's are both the same. So what I have here now is I have 2 minus 9 mu equals 3 mu. Add the 9 mu to both sides. 2 equals 12 mu, and so clearly mu is equal to 1/6. Don't write that as a decimal, leave that as a fraction. Now normally at this stage you would then work out the value of lambda, which I could, and then I could put both into this expression at the top here and work out OC. But if you look at the expression for OC here, the one I've written in blue, it only uses mu. I do not need lambda to work out my vector, so I'm not going to work it. I'm just going to do a substitution straight in now to OC. So I can see here that OC is equal to 3 multiplied by 1/6 A plus 9 multiplied by 1/6 B. So that is 3 over 6 A plus 9 over 6 B, which is equal to a half A plus 3 over 2, or 1.5 B, and that's my vector O to C. Checking back at the question asks us to find the vector method for a ratio of OC to CE. So I have OC, so now I need to work out vector CE. So vector CE is equal to OE minus OC. Now I have both these vectors already written from before. So just to recap, OE was equal to 3A plus 9B. And I'm taking away OC, which is the one I've just calculated. So I'm taking away a half A plus 3 over 2B. That gives me, what does that give me? It gives me 5 over 2A plus 15 over 2 B, or if you prefer it, 2.5A plus 7.5B. And we'll learn look at the ratio here of O to C, C to E. So O to C, C to E. Well, if we look at the coefficients for A, we have, for OC, we have a half, and that compares to 5/2. So 1/2 to 5/2, well, that is exactly the same ratio as 1 to 5. So that would be my answer for my ratio. But we can double check, because if we look at the ratio of the coefficients of B, we have 15/2 compared to 3/2. And that again would be a ratio of 15 to 3, which simplifies to 5 to 1. So it's exactly the same ratio. And there my question is complete. It is a lot of work, a lot of writing. I say, if you actually summarize this yourself, you'll probably see steps you'll just logically drop out. But here, hopefully you see pretty much every step you need to know and the logic behind the entire question. It is a difficult question. And my advice is always leave the vector questions till you've answered everything else you know you can do in the exam.